All right, so this is your review for your test for 9.2 to 9.4. So with the first section, we're just stating each of the transformations. One of the ones that I want to focus on. So again, I just want to focus on the ones that are most similar to the ones that you'll see on your test. So the first one we're going to look at is number 3. We have g of x is equal to negative 1/3 x minus 5 plus 3. The negative that's out in front deals with a reflection, and it is in front or behind, so it goes vertical. So reflecting vertically goes across your x-axis. So it's a reflection across the x-axis. From there, you have that 1/3 in the parentheses. You want to take the reciprocal of that, which is 3. So you have a horizontal stretch by a factor of 3. Next, you have that minus 5. So we're going to the right 5 units. And then that you have that plus 3. So we're going up 3 units as well. You do need to remember that if you have a negative inside your parentheses, you have a reflection across the y-axis. If you have a number, like a coefficient of the, like in front of the parentheses, in front of the radical, in front of the absolute value, you have a vertical stretch or compression. If the number is greater than 1, it's a vertical stretch. If it's less than 1 but greater than 0, it's a vertical compression. Inside the parentheses, if you have a coefficient of x, if it's greater than 1, once you take the reciprocal, you have a horizontal stretch. If it's between 0 and 1, once you take the reciprocal, it's a horizontal compression. Remember also left to right, or left or right, is inside the parentheses. Up or down is outside after parentheses. For the next part of your lesson, I'm going to focus on operations of functions. For examples 8 through 17, you're told that f of x is 2x plus 5, and g of x is x squared plus 4. For the first one, number 8, you're doing f of negative 3. So you're just plugging in negative 3 for x in f of x. So it's going to be negative 2 times negative 3 plus 5, which gives us 6 plus 5, which is 11. For number 12, I'll go back to number 9. But for number 12, you have g plus f of x. So you're going to take g of x, which is the x squared plus 4. And you're going to add it with f of x, which is the negative 2x plus 5. You can just rewrite this without those parentheses and combine like terms. So your like terms here are the 4 and the 5, which give you x squared minus 2x plus 9. Remember, if you have something like f minus g of x, keep the parentheses around each expression and distribute that negative into the second set of parentheses in order to subtract. If you look at 13, you have f times g of 1. So we're going to take f of x, which is the negative 2x plus 5, and multiply it by g of x, which is x squared plus 4. When you FOIL these out, you're going to have negative 2x cubed minus 8x plus 5x squared plus 20. Plug in that 1 in for all of your x values and simplify. So that's negative 2 times 1 cubed minus 8 times 1 plus 5 times 1 squared plus 20. The 1 cubed is 1 times negative 2 is negative 2. The negative 8 times 1 is negative 8. 5 times 1 squared is 5. And that 20 gets dropped down. So negative 2 minus 8 is negative 10. Plus 5 is negative 5. Plus 20 is 15. I'm going to skip to number 16 and then 17. For 16, we have f of g of x. So we're taking f of g of x, plug in your g of x for x in f of x. So you're really doing f of x squared plus 4. So we're going to have negative 2 times x squared plus 4 plus 5. Distribute the negative 2 in. We get negative 2x squared minus 8 plus 5, which simplifies to be negative 2x squared minus 3. For 17, we have g of f of x. So again, this is the same exact thing as saying g of f of x. So we're plugging in f of x for x and g of x. So it's going to be g of negative 2x plus 5. This is going to give us negative 2x plus 5 squared. If you want to write it as negative 2x plus 5 times negative 2x plus 5, you can. And you have that plus 4 after. FOIL that out. You're going to have 4x squared minus 10x plus 25 plus 4. Combine your like terms. You have 4x squared minus 20x plus 29. Alright, so at this time I want to go back to number 9 and do 9 and 15. For number 9, we have g of f of negative 3. So this we can rewrite as g of f of negative 3, which means plug the negative 3 in for x and f of x, simplify that, and then plug that in for g of x. So this is going to give us f of x is that negative 2x plus 5, so f of negative 3 is negative 2 times negative 3 plus 5. From there, this gives us 6 plus 5, which is 11. So really, we're doing g of 11 in order to find our answer. So we're going to plug 11 in and do 11 squared plus 4. The 11 squared is 121, plus 4 gives us g of f of negative 3 is equal to 125. For 15, we have f of 2 over g of 2, because f divided by g of 2 is the same exact thing as f of 2 over g of 2. So we're going to plug in 2 for f of x. So we're going to have negative 2 times 2 plus 5, and put it over plugging in 2 in g of x. So that's 2 squared plus 4. This gives us negative 4 plus 5 over 4 plus 4, which simplifies to be 1 over 8. For our next section, it has to do with inverses of function. You'll see that I've actually added some questions to this to better reflect what you will see on your test. So for the first 2 questions, you're just determining whether each function is invertible. So do your y values repeat? With number 20, your first two ordered pairs have the same y value, so that one is not a function. So the inverse is not a function. For number 21, you have 2, 3, 3, 4, and 4, 5. If you switch these, since none of your y values repeat, you can just switch the x and the y. You're going to have 3, 2, 4, 3, and 5, 4. And those will be the points for the inverse of that function. Next, we're going to look at number 22 and 23. For 22, we have f of x is equal to x minus 5, and we're finding the inverse of this. Remember, change that f of x to be y, and then switch your x and your y, and resolve for y. For this one, we just have to add the 5 to both sides, and we get y is equal to x plus 5. Remember, this does not indicate that it's the inverse, so make a note of what you started with, which was f. You're going to write this as f to the negative 1 of x is equal to x plus 5. For 23, we have the function f of x is equal to 3x minus 5. We're going to change the f of x to be y, and then we're going to switch x and y. So we have x is equal to 3y minus 5. You want to resolve for y, so we're going to add the 5 to both sides. we have 3y is equal to x plus 5. We divide each side by the 3. We have y is equal to 1/3 x plus 5/3. Again, you want to change that y to be representing the inverse, so that's f to the negative 1 of x is equal to 1/3 x plus 5/3. The last part that we're going to look at are these last 3 problems. We're just going to be stating whether each of these functions that are given are inverses of one another. So I'm going to actually skip over to a page that's got these, and we're going to do these so we have a little bit more room over here. So for 26, we have f of x is equal to 1/2 x minus 4, and g of x is equal to the square root of x plus 4. Remember with these, if you take a number, let's say I want to do 2, and I plug it in for f of x, I'm going to have 1/2 times 2 minus 4. Whatever I get from this, I'm then going to plug in for x and g of x and simplify that. If you get the same thing once you simplify g of whatever as you did that you plugged in for that f of x, then you have inverses of one another. So for this one, the 1/2 times 2 is 1 minus 4 gives us -3. If we take the -3 and we plug it in for g of x, that's going to be g of -3 is equal to the square root of -3 plus 4. We can't take the square root of -3, so these two are not inverses. For 27, we have f of x is equal to 3x plus 5, and g of x is equal to 1/3 x minus 5/3. If we take f of x and we plug in 2 for x, we're going to have 3 times 2 plus 5. 3 times 2 is 6, plus 5 gives us 11. So then we find g of 11, that's going to be 1/3 times 11 minus 5/3. The 1/3 times 11 is 11 over 3 minus 5 over 3. 11 minus 5 is 6 over 3, which is 2. You will see that that 2 is what you plugged in for x and f of x. The 11 is what you plugged in for x and g of x. So we are good. These two are inverses of one another. And for our last one, we have f of x is equal to the square root of x plus 7, and g of x is equal to x squared minus 14x plus 49. For f of x, if we plug in 2, or sorry, let's do 4 so that way we can actually take the square root of that. So if we have the square root of 4 plus 7, this is going to be 2 plus 7, which is 9. We then take we take 9 and plug it in for g of x, so it's going to be g of 9 is 9 squared minus 14 times 9 plus 49. From here, that 9 squared is 81. The negative 14 times 9 gives us a negative 126. From here, we have 81 minus 129, 81 minus 126. That gives us negative 45. Oops. Plus 49 gives us a positive 5. That 5, it's a 4, not a 5. The 4 is what you plugged in for x and f of x. The 9 is what you plugged in for g of x. So these two are inverses.